Hello, I'm Brian Farrell, and welcome to On the Introduction to Network Devices, Part 1. Today we're going to be talking about Layer 1 devices, Layer 2 devices, and then we're going to conclude with Layer 3 devices. There's a fair amount of information to cover, so let's go ahead and dive into this session. Of course, I'm going to begin with Layer 1 devices. Well, before I start talking about the Layer 1 devices, we need to talk about the Open System Interconnection model, the OSI model. It was developed as a way to help disparate computing systems to communicate with each other. The OSI reference model has 7 layers. Layer 1 is the physical layer, Layer 2 is data link, Layer 3 is network, Layer 4 is transport, Layer 5 is session, Layer 6 is presentation, and Layer 7 is application. We're going to be discussing the bottom 3 layers, layers 1, 2, and 3 today. Now, most devices do function at more than one layer of the OSI reference model. But when it comes time to determining where they fit into the model, you must first determine the highest level at which they operate, because that's where they fit into the OSI model. To do that, you must know what they do and how that relates to the OSI model. And with that, let's talk about analog modems. The word modem is actually derived from a contraction of modulator, demodulator. Modems were developed to take a digital signal coming from a digital node and convert it to an analog signal, modulating the signal, and placing it on a wire. In return, it would accept an analog signal from the wire and convert it, demodulating the signal, back to a digital signal that the node can understand. Modems were developed to create a connection between network segments via the public switched telephone network using the plain old telephone system. Now, modems provide for a single connection to a network, and they're only concerned about the wire. And the wire resides on the physical layer, layer 1 of the OSI model. It doesn't care where the signal comes from, it just does its job. Then there's the hub. A hub functions as a concentrator or repeater in that it doesn't care where the signal comes from or where the signal is going, kind of like the modem. It takes an electrical signal that arrives on a port and replicates that signal out all of its other ports. A hub may have just a few ports or it may have many ports. And for a variety of reasons, the hub is not very common anymore in the modern network. So now let's move on to Layer 2 devices. The first Layer 2 device that we're going to talk about is the switch. A switch utilizes an application-specific integrated circuit chip, an ASIC chip. The ASIC chip has specific programming that allows the switch to learn when a device is on the network and which ports it is connected to via that device's Layer 2 MAC address. That's what makes a switch a Layer 2 device. A switch may have just a few ports or it may have many ports, kind of like the hub. And although a switch is smarter than a hub, it can still be very simple or it can be highly complex and programmable. A switch can only communicate with local network devices. Another Layer 2 device that we need to talk about are wireless access points, the WAP. A WAP is a specific type of network bridge that connects or bridges wireless network segments with wired network segments. The most common type of WAP bridges an 802.11 wireless network segment with an 802.3 Ethernet network segment. Just like a switch, a wireless access point will only communicate with local network devices. Now let's move on to Layer 3 devices. And first up is the multi-layer switch. A multi-layer switch provides normal Layer 2 network switching services, but it will also provide layer 3 or higher OSI model services. The most common multi-layer switch is a layer 3 switch. It not only utilizes an ASIC chip for switching, but that ASIC chip is also programmed to handle routing functions. This allows the device to communicate and pass data to non-local network devices. A multi-layer switch is a highly programmable and complex network device. A multi-layer switch may have just a few ports, or it may have a lot of ports. They're not very common in the small office, home office network because they're really expensive. You're more likely to find them in an enterprise local area network. Now let's move on to the router. A router is the most common network device for connecting different networks together utilizing the OSI model's layer 3 logical network information. That's what makes a router a layer 3 device. The router uses software programming for decision making as compared to the switch's use of an ASIC chip. The router uses this programming to keep track of different networks and what it considers to be the best possible route to reach those networks. A router can communicate with both local and non-local network devices. In most cases, a router will have fewer ports than a switch. Now that concludes this session on the Introduction to Network Devices Part 1. We talked about Layer 1 devices, we talked about Layer 2 devices, and we concluded with a couple of Layer 3 devices. Thank you for watching this session. I'm pretty certain I'll do another one.